This is a shiny app for analyzing Clot lysis curves. When the app launches, it loads a set of data which is useful for exploring the available settings. The first tab, called Plots, consists of a main panel showing plots of 12 curves from a microtiter plate Clot lysis assay. Below this there is a group of radio buttons which are used to select which results are shown in the table below. The default setting is time to 50% lysis from the start of run. The names of the other parameters that can be selected should be sufficient to explain what is being calculated by the app. By clicking this symbol in the bottom right corner, you can expand the plots to a full-page view for closer inspection. Click here to close. To the left of the main panel there is a box of options that can be changed to optimize the way the curves are analyzed. It is helpful to investigate these settings using the data provided to see what they mean and how they affect the calculated results. At the top left there is a button to load your own data when you are ready. Data should be formatted as a table consisting of a column of time followed by any number of columns of absorbance readings. The columns should have headings, time, A1, A2, etc. You can see how this should look from the Raw Data tab on the main panel. The app will detect and accept CSV, text and Excel files. If you have an Excel file with multiple sheets, you can specify the sheet number using this input box. When you load your own data, you may want to change the number of rows to plot. For example, a full microtiter plate will be 8 rows. Next are 2 analysis settings which are usually okay as they are, but may be changed. It is common to calculate time to 50% clotting and lysis in this type of assay, and this is the default. The interpolation threshold is more difficult to explain but is an absorbance value below which answers are given as the nearest reading rather than interpolated between readings. Mainly, this avoids problems in empty wells. However, if for some reason your data are noisy, you can also simplify the calculations the app performs by setting a high threshold, higher than the readings you observe. If you do this, all the answers generated by the app will be at the closest time point or absorbance point in the data, and not interpolated between points. This is obviously less accurate but may solve some problems where the app crashes while trying to interpolate noisy data. There are 3 baseline options to choose from, as shown here. These are important as they affect the range of the absorbances used to calculate clotting and lysis times. Therefore, it is worthwhile spending time to choose the best option for your data. The default setting for the loaded data is a global zero absorbance value of 0.042, which corresponds to the average final readings in the microtiter plates after complete clot lysis in this experiment. You may observe a different absorbance reading with your own data, or you may want to use an initial reading before clotting begins. The next possibility is to choose a reading from your data and then its associated value will be the zero absorbance. In this case, point number 54 is used because by that time all the clots are fully lysed. The third option is to select the minimum absorbance of each curve and add an optional offset value. The offset value is judged by eye to give a sensible point on the lysis curve for complete clot lysis. The minimum absorbance alone may give a complete lysis time long after it has actually occurred due to noise in the final stages of the curve. At the bottom of the left panel on this page there are settings that allow you to use raw data or to generate additional points as a spline curve through your raw data points. In most cases it will be much better to leave these settings as they are and work on your raw data. However, if for some reason you have a low density of points in your curves, then it might be beneficial to add some more. You can specify how many points the curves should have and what times to start and end your generated curves. This is also a way of truncating lysis curves that have been monitored for too long. You may also want to use curves with more points if you have used a high threshold value so there is no interpolation, as explained earlier. In this case, more points will improve precision. Overall, it is strongly recommended where possible to stick to using raw data and perform interpolation. So using the default settings for interpolation threshold and raw or spline fitting. The second tab, labeled curve, allows you to examine individual wells from your assay. The layout should be self-evident, so on the left is a box where the curve of interest is selected from this drop-down input box. The curve is shown to the right, and below this there is a table of results for that selected curve. You can show all results, meaning clotting and lysis, or just clotting or lysis, using these radio buttons. The curve can be expanded to a full-page view using this button, as shown previously for all the plots. The third tab is all results, and as might be expected is a table showing results for all parameters and all curves. There are some parameters shown that are not available on the plots or curve tabs that relate to plotting the colored lines, but these are unlikely to be useful for your work. It is possible to copy and paste this table to keep a record of your results, as it is with tables and figures on all tabs. The fourth tab is raw data and is simply a table of the data currently being analyzed. Either the data provided when the app launches or the user's own data. The provided data shows the expected format where there is a column of time followed by columns of absorbance readings. The app is written to expect the first row to be column headings. The fifth tab is called Explore and is a simple way to take a quick look at the results of your analysis. Let's load some more interesting data to demonstrate what can be done. The default settings show a heat map of clot lysis times, but what is displayed can be easily changed in the panel on the left. Scatter plots are also available and are useful for looking at relationships between parameters. You can hover over the points with the mouse to see the results and well number. The sixth tab is called Settings and presents a table of the settings currently in use, along with the file name and unique identifier of the dataset being analyzed. It may be helpful to copy and paste this table for future reference to keep a note of the conditions that were used to generate your results. This tab is an aid to quality control and reproducible analysis. The seventh and final tab is for help and provides a brief summary of how to operate the app. In the left panel there is some information about citation when the app has been used for published work. You should also provide a link to the website of the app. My email address is also provided, and I urge you to get in touch if you have any questions, or you experience any difficulties in loading or analyzing your own data. I am always interested to find out what my apps are being used for. If you do have some problems, there is usually a simple explanation and solution, and I try to respond very quickly to queries. If you have any suggestions for improvements or new apps, I am also interested in hearing about these. If you do get in touch for help, please provide the name and version number of the app and a description of what is going wrong, and any error messages. If possible, please also send the data file that is causing problems if appropriate. Good luck.